As a software engineer, at some point on your career, you've either stumbled upon or worked on some potato code. And whether you were like junior or just starting out as a software engineer or a junior developer or even a senior developer, we have all worked with potato code. We've written potato code before, but we've learned from our mistakes, right? Hope you guys did. Because in this video, I'm going to show you how to differentiate between potato code and clean code. Like, what is the difference between this potato code and this clean code? If you can clearly see in here, I've got this e-commerce product page in here that showcases two different types of code that outputs the exact same thing. So for example, we've got the potato code in here, which just simply shows the product page of like the name, the price, the description in here, like product details, key features for you to select the different types of colors, and buy now or add to with reviews, specifications, and stuff like that, and the different images of the chair or the product you want to buy. So I mean, looking at this page in here, it looks pretty good, right? It works. It allows you to add to cart. It allows you to buy the products. Everything absolutely works fine. The end user is not going to notice that this is a potato code or a clean code or a good code or very garbage bad code. Nobody's going to care. The end user is going to work fine. And it's barely going to notice anything besides some performance issues. Now, if I switch to the clean code version, as clearly see in here, they are absolutely the exact thing. So like I'm switching between these two different types of codes, and the output is absolutely the same thing, like exactly the same thing in here. So yeah, you can't spot a clean or garbage code just by looking at the user interface, so you gotta dig deeper into the code itself to see the difference. So for projects in here, we've got two folders. We've got the clean code folder and we've got the potato code folder. Both of them have different types of files, and both of them, as you've seen already, that they render the exact same thing in here as like the product page or the e-commerce product page. But if you dive deeper into every single one of these types of codes, you're going to find a lot of issues. So let's go ahead and get started to see like how you can differentiate as a software engineer between potato code, clean code, and how you could simply just like avoid writing potato code. And when I say potato code, that means absolutely very bad code that is very hard to read, very hard to maintain, maybe has some performance issues as well, memory leaks, very bad code, and it's like, in general, very, very bad written code. That's what I mean by it. And I'm gonna like showcase this in React, like using solid principles and everything like that. Because if you don't know already, we've already put a book, solid principles, applied in React in here, and I know so many of you guys have enjoyed this. I hope you guys like learned a lot of how to write clean code using solid principles and best practices in React in here, and like leveled up your React code in general from somewhat bad to better, cleaner code, hopefully. So if you haven't already, you can go and check out the code at solidreact.dev, and you can just go in and get it now with like 33% off. So you can go in there, you can find link description below. But we're gonna basically apply like what I know from writing the solid React book in here, and try to like apply it to our today's video to differentiate between potato code and clean code. So first things first, let's go ahead and look into the folder structure of the potato code. So the potato code in here is clearly in here. It has up.tsx, it has components, and it has a couple of components. So first impression, we know that there's some like code splitting between different components. It's not like being put all at the same level, which is great. If you go inside of the up.TypeScript in here, which is the main application, it's doing pretty good. It's have header in here. It's importing the different components like product stuff, info stuff, cart stuff, and the different miscellaneous things. So it's pretty good. And got the footer in here. So far, so good. So we're going to try and access one of these components. For example, the product stuff. So first impression in here, going to the product, there is absolutely no naming conventions, and particularly the names in here are not like obvious or like easy to read. So when you say P in here, I might know what P means, but I absolutely have no idea. So P is very, very bad name. So like naming variables overall in this potato code is absolutely bad. They're like, there's no naming conventions. If you go into this prod, script in here, it's all being put using comments, but not the actual like variable name in it. So for example, I stands for ID. And how am I supposed to know that? There's no way I would know that. There's the N for name, there's the D for description, P for price, images in here, somewhat recognizable. V for variant. Okay, I would have never known that. There's the DET for details, crazy, and R for reviews. Okay, so this is a very, very bad naming convention. You would never want to do that. Or you want to simply just go in and name it like ID or name. Just give it the actual name of that and name, like, give it very explicit names, like what this one does exactly as is. Even though the name becomes a little like longer, it's still fine as long as it's absolutely readable, very easy to read. And as a developer or another developer joining the team, take a look at your code, they can easily know exactly what the variable means. So yes, that's a very, very important step. So if I go into a code base and I find variables named like this, I get absolutely terrified to continue reading or even touch the code to begin with. So that's actually very bad. You never want to do that, as I said before. All right, so that's the first bad thing about potato coding here. Looking again, we've got same thing in here, naming convention. So we're using state. We've got handle click in here. We're not using any callbacks, which we should, like use callback or something, but that's like more of a performance thing. If the components becomes too large, that's not a clean code thing, honestly. There's class names in here. They look fine somewhat. Yeah, so going back in here, we got p.image.map. Again, naming conventions. Man, this is very hard to read. And I notice also we're using a button. We're not using like a reusable button component. So this is, I think every single time we try to use the same button, we put the exact same styles. So we violate the DRY, which is the don't repeat yourself sort of like principle, which, you know, you always like repeating the exact same thing, even though all you could have done is just simply copy that button into its own separate components and put it over there and just reuse that same components. That would have made your life a lot easier and way much better. So the button here is very bad. That's as far as I can think of for product stuff. As you can see here already, like because I'm using Cursor AI, already told it to like generate the code for me. It already tells you bad practice, unclear variable names. Bad practice, no proper error handling or type check-in. Because we're using any in here for TypeScript, that's another thing. You got to switch that to number. So that's very bad. You never want to use any inside of your TypeScript code or TypeScript project. Same thing in here for any. Here, duplicate styles are set before DRY. And for image as well, there's a poor image handling. There's no alt. It's more of like an accessibility thing, not of like a clean code. But still, it's still very bad. Now, if I try to look at the same code on the clean code in here, so clean code in here, first like has already cool structured folders, so components. Inside of it, there's another good structure. So layout, for example, products and UI, like reusable UI components for a button, select in here, quantity input. So stuff like our reusable and common components that are reusable across the whole, you know, basically projects and anything. So that's pretty good. I love the folder structure in here, makes it super easy to read. That's another plus for it. If you look at so we got product details. So for this product stuff, for us, it's going to be split into multiple stuff. So for example, product gallery is what that one means. So product gallery in here is like, if you look at the code in here, just like first impression, you know exactly what's happened. You know that this is a gallery. Product images, and the prompts in here takes images of product image. If you look at the product image in here, you know that has an ID, URL, and an alt. Simple as that. If it takes images in here, there's two states. So the states are clearly named. So the selected index, set selected index is zoomed, set is zoomed in here, which is pretty good. There's the handle thumbnail click. You know exactly what it's doing. It's like setting is zoomed false to or set selected index to whatever index that is. Handle main image click. You make it unzoomed, like you trigger the zoom in here. If you go to the GSX as well, it's pretty straightforward as I said before. So div in here, we've got an image with a proper alt. As far as in here, we know that's selected index, it's giving the URL. Like compared to the previous one in here, it's very hard to tell what is this. What is SEL? I mean, yeah. But naming it selected index, it just solves a lot of problems. And yeah, it fixes a lot of issues said before. We're still doing the on-click as well. Now, for the thumbnail section in here, we're doing the same thing. Images, we're mapping through that, and we're going through every single other one. You may be wondering like, oh, we're using the same button here. Well, I just realized this is a custom button because we want to display like not a button, but more of like, you know, we want to style it however you like. So this is the right way to use it. And also here, it's the right way to use it. Or besides, it's the only way to use it for that bad potato code. So we got the button here. That's pretty good. Now, jumping back to our product stuff or potato code in here, if we look into the info stuff, so the info stuff are going to be stuff like product details and the key features in here, like info about the product, basically. So info stuff in here, again, it takes products in here. There's the formatting of the pricing, probably. Yeah, pool price formatting. There's the extra specs in here, which are defined in here. It's still fine. I mean, you would expect this from an actual API, but we just using mock data in here. So far so good. If we go back or scroll down a little bit in here. So far so good. It's not really that bad. I mean, besides the naming convention in here. If we look into here, we're doing objects entries and we're using any in here for type. So I think that's bad. Also, I don't know what is this one doing. I don't exactly understand what is it doing. So K equals MAT, so material. Oh, I think we put in, we put in, like, this is the thing. So material, and you can like put what type of material that is. Oh, it's basically for rendering everything, like the weight, dimensions, and material. Okay, that's not the best way to specify that because we're accessing the specs. Okay, it's not really that perfect. Somewhat acceptable, but not really that good. And we're using Regex right inside of here. Not really that good again, but acceptable for whatever that is. It's rendering. And yeah, again, so clear naming in here. Even naming inside of like your map or for sort of like parentheses in here, you would never want to use just one character. That's outdated. That's like from the old era of C and C++ and everything before that. That's really, really bad. It just makes it super hard to understand. I mean, whenever you see an I immediately assume that's an integer. I mean, it is an integer in this case, but it's not always an integer. And for example, it's an item. So I want to name this an item, right? I could use an I as well. That's not good. Proper naming convention is absolutely necessary for anything, literally. Even if you're working in design, it's way much more mandatory. So again, that's a really bad code in here. Also, it's not splitting stuff. So for example, it's putting everything in here. So this is actually rendering the name of the product and the price, which is right here. So it's putting all of this all together. I mean, for me, I would have like split this into multiple parts because that would make it easier to read, right? Because I don't know what I'm dealing with in here. And it's clearly violating the single responsibility principle that is from the solid principles that we've like covered throughout the book. That just simply tells you that one component should do one thing only instead of like too many things, and it just becomes crumbled like this. So back to our clean code in here, which should follow the good principles in here. So if we go to product, we go to product info. As you see in here, it's already like following the SRP principle, the single responsibility principle. So you've got the product header, the product specs in here. Both of them are inside of the product info. So as soon as I go inside of product info, I immediately get greeted by two separate components, which makes it super easy to like identify and work with. So I know first there's this product header, and it's actually combined between both of these two components, the product header first, and then the product specs. And if I want to check out the header, I click on it and it's just going to take me to the header with a title and description. Otherwise, if I want to go ahead and take a look on the product specs in here, which you can give me like the product details and like the key features of that product, I can go to that component and make the changes. So this makes it super easy when you use the SRP or the single responsibility principle, and you kind of like split the components depending on what each component does. So you make sure the component does only one thing, and even like if it does or it feels like it's doing multiple things, but all of these things are related and they're like under the same umbrella. So as long as that is actually pretty fine. As long as I go inside of like the product header, for example, it's rendering both title and description, but still the same umbrella, right? The same kind of like section of the component. This simplifies things by a lot. So this, like our clean code in here compared to the previous potato code, when it comes to the product info, it's so much better and so much easier to read. And yeah, if you want to check out OCP, you can go to the UI in here. Inside of our button, you can clearly say that we're actually following the open-close principle in here by providing different variants. That means every single time we want to add a new variant to the button, we can simply add the variant in here. It's not going to cause a lot of changes in here, only like the style changes. So adhering to the OCP in here, it's going to make your life a lot easier, believe me. I've been there. I've been like there and just doing everything all at once, and I don't know exactly what path I'm following and principles I'm like applying, and it just made my life or my code way much messier and harder to debug. Of course, especially debugging, man. I mean, it's so hard to debug a messy code. It's just gonna like make you break the keyboard or even the mouse or even the screen or the MacBook. I mean, yeah, it's the most expensive thing, but OCP in here is super good. So like giving control away to the user through the component props in here, it's just going to make it quite easier and just like adhering to the OCP. Now, back to our product info in here, there's actually a really good thing in here that we are following the interface segregation principle, which simply states that if a component, for example, this product info component, it only needs a couple of props. For example, the product in here, the product type or interface includes plethora of stuff from ID to the reviews in here. And of course, for our product info, we don't need stuff like reviews, for example, right? Or maybe, we don't need images. We don't need these images at all because all we need name, description, price, and details. So that for interface segregation principle, you only need or you only depend on the fields or the properties that you need. So that's exactly what we're doing in here using the pick. So that means we pick only name, description, price, and details. We disregard all the rest of the other fields. We don't need them. And that's just going to make our products. The same thing in here goes for the product header. The product header needs name, description, and price. If you go inside of it, you see the interface in here, we only pick in name, description, and price. As simple as that. Same thing for product specs. It only needs the details. So we go inside of it in here, we are immediately just putting the details in here. We're not even putting the whole products, but just what it needs. And this is what interface segregation, so like you separate the different fields of like different interfaces into the component you're passing it through just to make it easier and like the developer or whoever is just going to maintain or write or read the code, they know exactly what's happening and they know exactly what the component needs as props. So imagine here just providing the whole sort of like products, like everything. And we all need, or the only thing we need is the details. That would be super confusing. And last but not least, I want to look into the up.tsx in here to just see the overall how everything is organized. For example, the clean code in here, the up.tsx, this is what it looks like. Let's go to the potato code, up.tsx in here, where we're rendering everything. This is like the main application thing. So potato code in here, if we look into the up in here, we're doing the header, which is fine. But if you notice for the product related stuff, like the product components, we're importing the different components inside of here, which means we're kind of like polluting the business logic of the product business logic, or polluting our main application logic in here with the product business logic, which is unnecessary. So we put in product stuff in here, we pass any props, info stuff, pass any props as well, cart stuff, pass any props, even though everything is pretty messy. This is really not good. Even miscellaneous in here, we're doing it like right below. So it's like everything is everywhere. But for clean code in here, you see that we've put together all of these components, we took them and we put them into one main component that's called product layout. So whenever we call this component, we know that this is actually going to render the layout of a product page, of a single product page of our e-commerce store. So clicking on this, of course, this is actually going to handle everything from states, click events in here for like rendering and formatting. We don't care what it handles, but what we care about, this handles and cares about or makes the necessary adjustments and states and everything to render a product layout or a product page. And of course, for the GSX in here, it's going to like put together all the different components for rendering a product. So like variant selector, product info is going to care about, passing through the different props that it needs, the event handling, the ease loading in here, yada, yada, yada. So everything is just like contained inside of the product layouts in here. It's going to make it so much simpler. So later on, you can call this product layout here in the up.tsx. Maybe you're calling it somewhere else. Whatever you call it, you're always going to end up with the same thing. Compared to this is not ideal. So sometimes when you take a step back and try to have a wider view of your code from a different perspective, you're going to notice a lot of flaws and a lot of issues. So hopefully the video actually gave you, some kind of like a new perspective to look into things, how solid principles are very important, how other best practices and code principles like DRY play a major role as well, like writing React and JavaScript code or any code in general. Those principles are like, just going to change your mindset and way of thinking. So it's very, very important to follow them or at least know about them as long as you're like, a software developer, whether junior, a senior, or a medium developer, just getting started. Those have no time frame or something. So since I learned those, I've been using them forever, since I worked with Java, even C++. So yes. So if you want to learn more about how to write cleaner code, as we've just seen, with applying different solid principles, applying different best practices for React and JavaScript, and many, many things, you can learn from the Solid React book in here that I've put together. I know so many of you guys already enjoy the book in here, and hopefully it's been helpful for you to write better code. But for those of you who hasn't gotten the chance to read it just yet, so you can head over to solidreact.dev in here, and it has 33% off for a limited time now. And of course, you can read more about the book in here, the reviews, if you would like to. You can grab even a free preview for one chapter before deciding to jump into the full book in here. But there's actually a massive discount going on in here with regional pricing as well. So you can go ahead and jump and get the book. You're going to receive it on your email in a PDF format with 144 pages. So anyway, hope you guys enjoyed. Hope you guys liked the video and how to write better, cleaner code in React. And see you all hopefully in the next video.